Okay, hey guys, how's it going?
Pretty good. Hi, everyone.
I'm happy to
Hello.
Hi.
welcome you at the HolyJS conference. You are opening the first talk, so I guess that's kind of honor. Martin, I'm so super happy to see you. It's like pity that we don't meet in person, but still. We can meet at the conference during this pandemic world. So I've already said that we're having a WebAuth talk today, and I guess I will start with this couple of small talk questions. The first question is easy. Why can't we use just password policy as usual? Why isn't it enough, Martin? Why are we talking about this?
Well, because it turns out that what is quite complex to us might not be super complex to computers to crack, and we have seen so many incidents where passwords have been leaked or have been stolen. And also, I'm not sure about you all, but my memory is pretty bad. So I used to reuse a password for multiple sites until the advent of password managers. But even then, they're not fantastically great. We'll talk about that in just a few minutes. I'll show you a few reasons why we really shouldn't be doing it, but let's just say it's not enough, and it has been proven to not be enough in the past.
Okay, Simeon, maybe you want to add something?
No. Martin say no.
Okay, but I've got a question for you too. As far as WebAuth doesn't provide any protection from losing your device, we still are going to some kind of old and not actually secure ways. Why would we need WebAuth in this case?
I guess Simeon will step on this and try to explain why actually WebAuth is important for us in his talk after the Martin.
Okay, so I guess that my questions are gone already. So are you ready to start, friends?
Yes.
Okay, so let's start with Martin's talk.
All right. So, as you have all heard, my name is Martin Splitt. I am a developer advocate at Google's web ecosystem team. I mostly work with Google Search, but I'm also working with the Chrome teams, so that's really, really exciting. And I'm at Google Zurich, so I'm in Switzerland, where it is, I think, 2 hours earlier than at your place, which means that I had to get up quite early for this, but I'm really, really happy to be here. I love to be at HolyJS in person, but as you know, the world has changed a little bit, so I'm really, really happy to at least be here over the internets. And tying into the question that I just tried to answer without taking too much out of the talk, why are we talking about two-factor authentication on the web? And the main reason is that passwords actually suck. And if you are like, no, hold on, I have all my passwords in my password manager and everything is wonderful and great, then let me explain to you why that might not be the case. So XKCD says it best, as usual. There's an XKCD comic for pretty much everything out there. Yeah, and no different for passwords in this case. The problem is that when we are making up passwords, for instance, using a password manager, or actually making our own system for coming up with different passwords that we can also remember, we're making our life really, really hard. So we take some sort of uncommon base word, then we are changing letters for numbers, and then we mix uppercase, lowercase, maybe we throw in some special characters. And this is ridiculously hard for us to remember because there's different variations, right? So we might only change some letters to numbers. We might sometimes change an O to a 0. Sometimes we don't. What is the special character that I used in this case? Where did I put it? Did I put it at the front? Did I put it in the end? Did I put it somewhere in the middle? Did I substitute a letter with a special character? I don't know. There's lots of opportunities for us to make these combinations up. But surprisingly, if you take a computer and make it guess this password, then there isn't as much change. So for this weird password, troubadour &3, which I would not be able to remember because, oh wow, I would not know when I substituted something for something else. That's only 28 bits of entropy. Well, what does that mean? Well, it means that we can probably easily guess it within a few days. That's not great. For something that makes my life harder every time I have to type in the password without a password manager, which sometimes happens, having only 3 days or a few days of crack protection isn't that fantastic. And then there are all the problems that I addressed earlier. There's like, which O did I substitute? Which one didn't I? Which special character did I use? Where was it? Did I add a number? What was the number that I added to this? It's not easy. It's not useful. But what if we just take a phrase instead of a password? So we take an entire sentence, really. That's easier to remember, because especially if this phrase for some reason means something to us, then like a catchphrase or something that your parents used to say to you every day or something like that, then that's very easy to remember because it's already ingrained into our memory. But it is surprisingly hard for computers to guess. In this case, correct horse battery staple, which you shouldn't use because it's now in the open, basically. So it's probable that this will actually find use in password files that are being used to crack your password quicker. But this is already 44 bits of entropy, so that would take a few hundred years. So this troubadour &3, a couple of days. Correct horse battery staple, a couple of hundreds of years. Which one do you think is easier to remember? Well, okay, to be fair, correct horse battery staple, that's not that easy to remember because it's a really weird sentence. But for instance, Yamagu no Yechachu or Yachachu no Yemagu, that's a fun sentence. That's one of the sentences I love the most in the Russian language. Even though I have the language level of like a 3-year-old, I can say, Меня холодно, я хочу спать, я хочу мороженое, like the essentials, basically. Who doesn't want ice cream anyway? But yeah, basically, passwords are not intuitive. When we pick random passwords, we might actually make our life harder and the life for computers easier. And picking good passwords sometimes is prevented. I've known so many forums where it's like, enter your password here to sign up. And then you enter something like correct horse battery staple. It goes like, no. It has to be between 6 and 12 characters. It has to contain one special character and at least one number. And you're like, oh, great. So my easy to remember, hard to crack system of making a password choice does not work here because someone decided that it's not secure. But then this insecure, harder to remember thing, that would work. Great, that's lovely. And there's a more fundamental issue here that many people, you know about password security issues, I know about password security issues, but lots of less savvy people who just happen to use computers and passwords as tools, they might actually turn out to just use the same email password combination for lots of things. So if you can guess one, then you can basically just log in into everything. So someone uses the same password for, let's say, some meme site like 9gag or something, as they might use for their email, their email account, or even worse, their online banking or PayPal account. So if one of these sites gets hacked and the password gets stolen, then the attackers might actually find that for many, many people, they can access their emails and their bank accounts now, which is a big problem. And 81% in 2019's Verizon Data Breach Investigations report of the hacking-related breaches where data was stolen is based on weak or stolen passwords. And to give you an example, Equifax, a huge multinational company, had admin as their login, username, and password in Argentina. And that's how a lot of data was stolen, because someone did not bother to replace admin. And you know how this works. Sometimes people are like, they're calling a consultant or they're having an administrator set up an account, and then it's like, here's your starter password. And it's like last name 123 or something like that. Please change it within the next 24 hours. How often has that not happened? That whoever was asked to change their password did not actually change their password. It happens a lot. We once ran a test at a previous company that I worked for to see how many people had changed the password from the initial password that we sent. And we happened to know the hash and the salts for these things. And then we basically just tried it out as a test on a beta program. And in this beta program, where the data was thrown away after a couple of weeks, pretty much no one had changed the data. Now you can say yes, because it was a throwaway beta program, but still, I'm pretty sure that would happen in production systems as well. So not great. And there's a bunch of problems. So passwords being hard to remember is one thing. they are also really annoying to manage. I mean, sure, password managers are great, but if you then like have to change between devices from work and private devices, and maybe in the office, and maybe it's a different device every couple of days because you're rotating desks and computers and stuff in a call center, for instance, then it's really, really annoying to manage, because then you basically have to migrate your stuff or take it with you on a phone, but then you forgot your phone at home and then you can't log in. It is annoying, trust me. They can be leaked, because if it's in a database and if someone was not salting it properly and hashing it properly, or the salt and hash has been stored somewhere like we did for this test, then they can just be leaked. You can break them with rainbow tables, even if they are hashed, unless they are properly salted. So even if you are doing everything to keep your password secret, there has been so many password breaches where databases have been stolen and potentially cracked as well. I wouldn't rely on that. And because it's just something you know, it's just a secret, it can be guessed, right? The Physicist from Friedrich Dürrenmatt is a beautiful theater play on the problem that something that you know is not something that you exclusively know, even if you are the first one to come up with a new concept. Someone else might think the same thought at the other end of the world and come to the same conclusions. That's why we have these patent issues where someone's like, no, I invented it first. No, that's not true. I invented it first. No, I invented it first. You actually invented it more or less at the same time. Good luck proving that. The same with passwords. If I can come up with a password, someone else can come up with the same password. It might take them very, very long, but it might not. We've seen that this troubadour password thing takes a computer a few days to actually come up and randomly guessing. So I don't know, it's not a good thing. So what can we do to fix this, and what can we do to overcome the password issue? Well, how about we take something that I know, like my password. So we're not replacing passwords, we're enhancing them, right? Okay. So I take something that I know, my password, my secret, with something I have. What could that be? Well, I have my phone here. You do not. What if I give you my phone? If I give you my phone, you have my phone, great, but you don't know my password. So this is something that explains this two-factor part, is that we have something I know, I have in my head, I can share that with anyone I want to, and something I have, which I can also give away and share with someone else. But if I only give you what I have, or if I only give you what I know, but not both of them, then you can't log in. Sometimes this goes even further. So for my online banking, for instance, I have my banking card here, and then I have this little device. So now I need to know my username and password. I need to have one of these. Any customer of this particular bank has one of these. That's fine. I can also trade it with other people. It's not, the specific device is not specific to me. But if I give you this device and my login, my username and password, you can still not do anything because you need my card as well. And if you have my card, that's great because you don't have my PIN. So this is something I have. The PIN is something I know. And this is something that you or I both might have. But it's basically, again, two-factor authentication, because with the PIN, this generates a number, and I need that number to complete the login process. So multi-factor authentication or two-factor authentication at the minimum is combining a secret with an object, a physical object of some sort that not everyone has access to. And there's different ways of doing this. So if I have my phone, if the phone is something I have, then someone can send me, or let's say like I want to log into my bank with my password, username, and my phone, they could SMS me. They can send me a text message with a code, and then I enter the code into the login form as well. And if you don't have access to my phone, then you can't get that code that was sent in a text message. Same goes with the email. Email is a little tricky because, again, that you could log into my email account if you would crack that password. So that's not necessarily great. So you have to have two-factor authentication for your email as well if you want to use an email system as a two-factor authentication. I can install an app on my phone like Authy or Google Authenticator, and then I can connect that to my account, and then I would get these one-time passwords. And that allows me to also have something that I have, the phone with the app on it, plus something I know with my password and username. If you have a fingerprint sensor like this phone does, then you can also use that. And in that case, you might actually not really need a password anymore, but we'll look into that in a bit. You can also use these security keys. I'm actually wondering if I have one here. Yes, I do, but I have the USB-C variation of it. So this is a security key for USB-C. It's tiny, as you can see, and it goes into the device I want to log in with. Security keys have a private key on it and a little bit of logic so that you can send it a message saying like, hi, can you please sign this? And then it signs something with a private key, and then the server, which has the public key, can prove that the signature was created with, for instance, this little device. This little device has a big advantage. I can plug it into a computer, but I can also plug it into my phone, right? So I can use this with pretty much any device that has USB-C, which is quite a lot of devices these days. Not all of them are equal, though. As I already hinted at with email, if someone else can log into your email, then that's bad. Then they have access to the thing that is your second factor. Same as with SMS. So this specific one is using what's called a SIM duplication method. So hackers can now bypass two-factor authentication with a new kind of phishing scam. What they effectively do is they get themselves a SIM card that logs in to the mobile network with your credentials by social engineering your mobile phone provider, which apparently works. So then they receive the text messages with the codes, and then that's not really the second factor. The security keys haven't been hacked so far as I'm aware. And as far as I know, the apps like Authy and Authenticator, they also haven't been hacked yet, I think. With the apps, it's a little trickier because if I install malware on that phone, but then again, if I install malware on that phone, I have a lot of options to do bad things. So we have a different problem than just the two-factor authentication. So email and SMS codes can be phished off of you. So that's not great. Hypothetically, apps could leak malware, information to malware. But the fingerprint readers and the fingerprint readers have been hacked, but it's a lot more effort than just logging into someone's email. And also the security keys, I don't know of any successful attacks for them either. So how did that all come together? So originally, two-factor authentication using security keys has been quite a hassle, and you needed to install plugins into your browser, which you might not be able to install. I'm not sure if there was a Linux plugin, for instance, if you're using Linux on your computer. But in 2012, Yubico, Google, and NXP said, we want a universal two-factor authentication method. So we want something that works for pretty much everyone, and we need to expose this in a way that actually works everywhere. More companies joined. It's now called the FIDO Alliance. And the U2F, so the Universal Two-Factor Initiative, is part of the FIDO Alliance's project list since 2013. And in 2014, the first couple of open source implementations actually launched. So now there are reference implementations for how to do universal two-factor, and they are all compatible with each other as long as they adhere to some standards. The latest standard is the FIDO 2.0 standard specification, which is an open standard. You can read the standards documentation on the FIDO Alliance's website. And as part of that, there is a new interesting API that a bunch of browsers already implement. I know that it's in Firefox and in Chromium browsers, so that means Opera and Edge are using it as well, or supporting it as well. It's called the Web Authentication API, or WebAuthn for short. Now, what is WebAuthn? What is this magical API that brings us as web developers the ability to implement two-factor authentication logins into our web applications? And it does so relatively pain-free, I have to say. It's really, really nice. It's a bit weird to get started at first, but once you're on the road, then it's like pretty much nice. There are a few edge cases, and I'm pretty sure Simeon will talk about all of these in his part of the talk, so stay tuned for that. But let's look at what are we looking at? How does this work? Well, there are a few players involved in an authentication run, right? It's me, the user. I want to log in or sign up for a service. Maybe your service, who knows? Then we have the authenticator. The authenticator is the device that you authenticate with, like this little security key here, or the fingerprint sensor, or the fingerprint sensor in my MacBook, or the app that I installed on the phone. Those are the authenticators. They are devices that hold a private key and that never leaves the device. The private key stays on the device. It offers two things. It can either give you out a public key, so it can create a public key and say, like, here's the public key of the public-private key pair. And it can get a request to sign a challenge, and then it signs the challenge with the private key, and the public key can be used to verify that this device, this specific device, actually signed the challenge by looking or by basically verifying the signature with the public key. Then there's the browser. That's the thing that the user uses to actually use or sign up or log into your web service or offering. And then there's the relying party. The relying party is your service. So this is basically your server. So if you are running Example Inc. At example.com, then you are the relying party. Example.com relies on web authentication to make sure that the user is who they say they are. And they do that by using the browser to talk to the authenticator. Then the user verifies to the authenticator. I'm not sure if you can see it, but there's like this little gold thing in the middle. Actually, do I have something pointy to point at this? Yes, I do. So there is this little yellow stripe here that you see, right? Whenever my browser is asked by your website to use an authenticator, my authenticator basically waits for me to touch that part. It's not a fingerprint sensor. It's basically just a button. It's just, is the user okay with this action? So you can't accidentally authenticate. If it's in my MacBook or on my phone, and I'm just sitting there going like, oh, why does it want me to authenticate a board? It doesn't happen automatically. I have to have a user gesture to make sure that the user is actually present so that no malware, if a malware would be like, please log me in, and my security would be like, yeah, sure, then we have 1-0. But if a malware goes like, please log me in, and I'm like, I'm not logging into anything, what is happening here? Then that's how I can prevent that from being successful. So I have to have a user gesture, and that's something that the authenticator does. And here, this authenticator also has a button. This is not like a fingerprint sensor. This is a button that you can use to also do that. So it's a user verification gesture. The user has to say, yes, I want to authenticate. So how does that work? So if I'm signing up, I'm typing in my email, typing in the password, a user name, and then the relying party says, okay, please give us a public key that we can use to later log you in. And then the browser basically asks the authenticator to do that. The authenticator asks the user to please press the button or show that you are there. So now we're basically gone from the relying party into the browser, into the authenticator. The authenticator waits for the user to press the button. The user presses the button. A public key is put into the browser. The browser can then transmit it to the relying party using a form, for instance, or a POST request or an AJAX request. I don't care. And then the relying party saves not only my username and password, hopefully a hash of my password, but it also saves the public key. And then later on, at some point in the future, when I'm logging in, what happens is the user goes to their browser, the browser requests the login, and the relying party says, cool, here's a challenge, please sign that with your authenticator. Then the browser says like, hey, can you please sign this with your private key so that we can have a signature? And then the authenticator asks the user, hey, hi, someone wants to sign something. You good with example.com wanting to sign something from me? And the user goes like, yeah, touch the little button. The authenticator uses its private key to build a signature over the challenge. The signature is put back into the form or the AJAX request, whatever you do, and then sent back like this signature is sent back to the relying party. And using the public key and the challenge, it can check if the signature that was sent back from the browser is actually the right one, basically. It has to contain the challenge, and it has to be done with the private key from the authenticator. Because the authenticator never gives away its private key, you can be sure that this is actually the right user signing up with the right two-factor authentication method. And there's like basically two processes specified in the API. There are a few more things that you want to implement on your site, but the absolute minimum are two things. One is the registration, which can either be literally signing up to your service at the get-go or adding a two-factor authentication method to an authenticated user. So basically you say like, okay, so this user is, as far as I know, the real user. how do you know when someone types in a new username and a new password and a new email address you've never seen in your database? You don't know if it's really them, but you can try to verify by sending them a verification email, and at least you know that that email address works, but you don't really know who they are. But at that step, they could add a two-factor authentication method to their freshly created account, or they can basically log in with username and password if you already have existing users, and then they can say, and now I want to add this security key to my account. So that's the registration process. And then we have the authentication process. Once you have a user that has signed up with their security device, with their security key, they could be like username, password, send, and then the server goes like, actually, are you who you say you are? Please sign this. And then you tap the little button, and then a signature gets sent back, and the server says, okay, yes, it's you. Unless you don't have this little device on you, and then it says like, no, username and password was correct, but you were missing the second factor. So roughly, the flow of the first process, the registration, is the service says like, please create me what's called credentials in the WebAuthn world. The browser then says, okay, so that's the WebAuthn API bit. So you say like, I want credentials to be created, so that your JavaScript in the website says, please create me credentials, and then the browser asks the authenticator, can you please create credentials? And the authenticator asks the user, you good? And the user says, yeah, sure. In which case, the authenticator creates a new public key and sends that public key out. So then there's a public key, and also creates a signature that the public key is actually matching the challenge from the browser. And then the browser sends that over to the server. Here, there's a public key and there's a signature that shows that this is not just something that we have pre-created, but this is something that you specifically asked us for. And then the server checks that the signature matches what the server expects, and then stores the public key for this user. So in your user database, you have an additional field that says public key, basically. So it's username, password hash, and public key. If you want to log in with two-factor authentication, the user basically types in username and password. The server checks, yeah, username and password check out. So this user exists. That's great. Here is a challenge, which is basically just a random string of data, so that you can't just have something pre-created, right? You need a different signature every single time because it's a random string of data. So the server remembers, okay, so for this user, I have this challenge. It's a random string of data again. Please sign that with your private key. To do that, the browser then says like, oh, okay, so hey, can I get the credentials for this website? And could you sign this random bunch of data? To which the authenticator says, okay, hey user, you okay with this? I press the button, so I say I'm okay with this. And then the authenticator goes like, all right, here we go, and gives my browser a signature back. And now the browser can send the signature to the server, and the server can then check that the signature is what it needs to be by basically running the random data that it saved as a challenge. On using the public key, it can verify that the signature is for that challenge and comes from the right private key on the authenticator. So that way, we use the stored challenge and the stored public key to make sure that this user is actually who they say they are, and they actually use the key they say they would. I already hinted at this. Passwords suck, not just because they can be leaked and someone else can log in as me, but also it just sucks to have to remember something, right? I just don't want to do that. And I was already hinting at it. If this is my only device, then I need a password, because if I give you this device and it's just username, and my username could be known because it's just like, I don't know, Splitty or something, or Martin Split, for instance, and I give you this, and that's the only factor that keeps you from logging in. Because if I give you that, you just press the button and that's it, right? That's not great. That's bad. So that's why we do still need that password, but we can get rid of it because, oops, that's the wrong way. Because these are not the only devices out there. There are devices that can actually verify that it's me, where I can give the device to you, but you can still not as easily pretend to be me. Here, with that one, 100%. You press that button, that's all we know. The user is there, the user is okay with having that happen. But what if I'm using this? This is my fingerprint sensor. I'm not sure how easy it is to actually see. There's a fingerprint sensor here. So if I give you my phone and say like, here you go, and you type in Martin Splitt into my e-banking, and then it says like, please authenticate using Web Authentication API, and my authenticator is this fingerprint sensor, then you have to put your finger on it. Your finger is not registered. So you put your finger on it, but the authenticator says like, hold on, you're not Martin. You're someone else. I'm not letting you in. I'm not signing this. I'm out. You have no way of using that. The same with this thing from my online banking. I can give you this. It's not a problem. I can give you this. I can even give you my card. That's okay. Here you go. That's your two-factor. There you go. Here you have it. I can send it to you via mail. It's not a problem. Because you see the keypad here? You need my PIN. So now, if the Web Authentication API asks you for that device, and you have that device, and you have my card, and you put it in, this device asks you for a PIN. So again, you can't get a signature because the authenticator says like, what's your secret PIN number? And you're like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0? And the device goes, no. Nice try though. I'm not signing this. So if you have an authentication device, an authenticator that actually verifies that the user is who they say they are, with a fingerprint, with a PIN code, with a password, which is a little pointless because password is basically what we try to avoid here, right? But if you have that opportunity, or Face ID, or I don't know, blood sample, don't know, then you cannot just say like, okay, the user wants to log in here with this mechanism, like this one does with a little button. But you actually can say, this is the user who they say they are. So this is the person that we are trying to get here. So in that case, we don't really need the passwords anymore. So we can use Web Authentication API with an additional parameter. So basically, when we do either the login or the sign up, we can say like this device should also verify the user. It's called user verification. If we verify the user, the password becomes optional, which allows us to a bunch of interesting things. Because we now know that the authentication is done by the person that signed up with it. So not just anyone in front of their computer, but actually the person we are looking for with a MacBook with a Touch ID, that would be the fingerprint in that case. If you put your finger on and the macOS goes like, no, you're not Martin, then you can't do this. So I have to be in front of my computer in this case. We can do a bunch of interesting things. We could, for instance, say like, okay, here's a high-risk action, online banking. And like, okay, logging into someone else's online banking is a bit tricky because I don't necessarily want you to know how much money I have and where I do send money to. But what's worse than that, if you were actually to pay someone from my money without my authorization. So what we can do is we can basically, like, if someone just wants to check how much money they have on their account, just put that after like a whatever. And if someone else does that, that's unpleasant, but that's not a risk. What is a risk though, is if someone would send money to someone else. So if I am logging in like quickly, like, whatever, username, password, okay, I still have enough money to buy, I don't know, this computer. Yay. That's great. But if you want to send someone money, then you would have to then use your fingerprint, for instance. You can also do things like, this is like a nuclear launch website, which you shouldn't really be building, but let's not talk about that. So we need to have two people, Bob and Alice, to both put their fingers onto their computers and then actually launch that nuke. You can build that with Web Authentication API if you want to. And you can do a lot more. And if you want to learn more, check out webauthn.guide. That's a really nice high-level guide that shows you with lots of examples how this works and how the flow works. WebAuthn.io has more information as well. And Herr Jemand on medium.com wrote a really, really good blog post series on how to implement that on your website. And with that, I'd like to open the floor for a few questions and then hand it over to Simeon.
Yeah, Thanks for the talk, Martin. It was really good, really great to hear about all those things. Unfortunately, we don't have questions from the audience, but I do have one question myself regarding password managers. So if you have a password manager that can also do authentication with a code that it's come through, like not the SMS, but OCR, this kind of stuff. In this case, you're putting your passwords and your authentication codes into one place, making it essentially like one factor. Does this pose the same risk as an email?
It kind of does, I think. On the other hand, I think a password manager that is installed on your device and doesn't like sync to the cloud or something, if it's really just on your device, then at least it is safe in your device. So someone would have to have access to your device. So they would have to install malware. If it's like a password manager on my phone that generates the code, then you would have some sort of access to my phone. So at least it's a little safer than my email account, which is literally in the cloud. So anyone with an internet connection can potentially get into my email. Unless it's also two-factor authentication protected, then it's a different story again. But yeah, it's not as secure as a separately physical device. But I would say it's somewhere in the middle between the two. So it is kind of breaking the two-factor authentication model, but at least it's better than something that anyone can access from anywhere.
All right, works for me.
All right, excellent. I guess then we hand over to Simeon.
Yeah.
All right, thank you very much.
My turn. Меня слышно? Да?
Yes.
Окей, good. Всем привет, меня зовут Семен, и моя часть доклада будет тоже на английском, чтобы ее все поняли, как и предыдущую, в том числе и мой партнер по докладу Мартин. Hello everyone, my name is Семен, and I have an idea for a place without any problem. It is Petsgram. This is the app for photos of favorite animals, and I'm looking forward to releasing it. Last smoke test, and I will ship it. Okay, I can see photos. It is my dog, Tiffany. Good. Trying to sign up. Oh no, I forgot about this to do. I didn't implement sign in and sign up flow. Okay, no problem. I'm professional. Let's go to fix it. But first of all, I need to define the requirements for the best of the best authentication and registration flow. The first, I want it to be easy to use. That users don't have to lose a lot of energy for sign in and even more for sign up to the app. Second, the ability to use multiple devices. For example, a user can sign up on a smartphone and then quickly sign in on a computer. The third, of course, everything should be secure, so that no one can steal my dog's page and start posting ads about some coins, for example. And let's start the most classic solution, login and password. We have many ready-to-use packages and tutorials on YouTube for Node.js example. It is a passport and passport local. And now little bit disclaimer. I will show only the front-end parts code because I'm not full stack, but you can check the simple backend code later by the link in the last slide. And one more, the front end will be without any frameworks because size does matter. And one more, authentication and registration, as it is fashionable to say, framework agnostic technology. Okay, we have to do login and password. Yep. Nice. We have some views for sign in and sign up. In sign up, go to sign up. I have 3 fields. It is name, email, and password. So, and small JS part for calling my API. I just listen my form submit and calling my API. In sign in flow, very same, but here I have only two fields. That is email and password. And very same JS part for calling my API. Also, I have parts for recovery flow password because user can forget password, and I have two views for forgot password and new password. Okay, look like it should work. Let's check in the browser. Okay, try to sign up. My name, email, and some password. Very difficult password. Sign up. Nice. In the app. And if I try to log out and sign in, as previously, login and password. Yeah, you can see interesting crash for the password vault. It is password manager, but I have good memory, never for this site. Very nice. Everything work, not bad. What are the advantages of the current approach? The first, users know this flow. Everybody know what is login and password. Second, having signed up on one device, knowing the login and password, we can sign in on another device. But what about security? Let's pretend we are a browser extension and we can see what users type into the password field. Just look. 1, 2, 3, 4, 5, 6, QWERTY, password. Is it just me, or can you brute force all of them in a couple of minutes? Okay, maybe try to teach my users how to make stronger password by implementing a password policy, and user will start typing more unique passwords, and they will be resistant to brute force. Before we had QWERTY, and after. Okay. Anyway, password are also leaking, so we still have to look for some other solution. Martin said about multi-factor approach. What is the factor? It is what I know, password, PIN code, what I have physically, credit card, phone, passport, case for my apartment, example. Wikipedia also mentions somewhere I am, like GPS, IP, but it is from the dissertation of 2005, and today this factor is used like half factor. In many cases, multi-factor authentication, it is a combination of the first two options. Many apps using SMS or push notification, like the second factor. SMS we have in real world SIM card and or phone, this eSIM. But SMS is so expensive for my project, and it is not secure too. Somebody can reissue my SIM card and use it, and SIM card not always confirm. A little bit story, when I was in India, I had to change my SIM cards all the time, but I needed to verify my actions in someone's app. Push notification sounds good, but I don't have a mobile app yet. I can use only web notification API, but it is not available on iOS devices, for example. But I think sending verification code by notification API, it is great use case than sending some promo info. Another common path to the second factor, it is OTP, based on time or HMAC. Usually, time-based prefer because it has a more smooth user experience. So try to do OTP in my project. Okay, nice. Well, I added two new pages, the second step sign in and second step sign up. What I did on the second sign up page, just look. So I draw SVG QR code that comes to me from the server ELSA secret. ELSA secret, like fallback for users from a smartphone. Next, I have a token field. Token field to check that the user has configured everything correctly. I could also add here recovery case, but not today. In JS part, nothing new. Just calling my API and everything well, redirect users to home page. In sign in page, very same code, but here I have only token field and little bit JS part. Okay. Let's check in the browser. Oh, yeah, very nice. Try to sign up. My name is same OTP, same gmail.com, and some password. Try to sign up, and yeah, I have a QR code. Try to scan it. Yeah, very nice. If I will have time, I can. Okay. 1, 0. Yeah, I have time. Yeah, ready. Nice. And if I log out and try to sign in, yes. In. Change the password. No, I have a very good password. And now I can type, but no, little bit later. Yeah, now I can. So 5, 3, check, and yeah, I ended up. Very nice, very nice. So, what do we have with the implementation of OTP? We have a random password, random PIN that changes every 30 seconds, and it is also cheap in the development of the second factor. Cool, but you know, when I have to deal with OTP, I feel like a SWAT team from Counter-Strike when I need to defuse a bomb. Time tick-tock, tick-tock. ELSA users need to have a special application to use. Nobody knows this flow. For example, my wife found out about it when I was preparing the current talk. And however, it is still not safe. This approach is subject to phishing, as is the first factor, login and password. How we can change it? Yeah, maybe try WebAuthn from Martin told. And WebAuthn implies to use a cross-platform case like UBK or something, and platform, Touch ID, Face ID, Windows Hello, etc. And I prefer to talk and use the platform because not everybody has special chip yet, but today almost everyone already has phones or computers with an authenticator on the board. Okay, let's try to implement WebAuthn in my application. Go to the code. Yeah. Oh. First, I renamed the second factor sign up page to add key. Because users can add keys in the second step sign up or later in the setting page if they want to add more keys. Look what changes inside. So We still have one field, but now it is authenticator nickname. These fields needs to manage them in the setting page. A more exciting thing in this JS part. Yeah. WebAuthn based on challenge response protocol. So I have two endpoints for this. First, it is add key challenge in my case, and add key verify for send response to the server. Okay, nice. What do I get from add key challenge? A couple of words about options. It is a random challenge. Some options about my server in WebAuthn world. It is a Reliant party. Some user info like ID and nickname. And other option, it is our requirements for user authenticator. If you want to know more about some options, ask me in the QA session, but they are very well described in NDM. Go to next. How you can see, some options required array buffer format, and I need convert. I need to convert them from base64 format to array buffer because format not support array buffer. Next step, I set these options to navigator credentials create. It is async method, and like from Martin talks, it is authenticator public key please. And if authenticator say, sure, here you go, I will have credentials. In credentials, I have ID, KID, KID, public key, counter from the security, counter for security from replay attack, and data about origin site for save from phishing. So next step, I convert some options from array buffer to base64 and send them to the server. And so that's all. If the server accepted everything, the user will be redirected to some page. Okay, in the second step, sign in, are more interesting. Yep. As you can see, I don't have a form anymore. I have one button, verify. After clicking on the button, I will call my API. Now it is key challenge endpoint, not add. Because now I will check previously added case. I receive from this endpoint a random challenge, some previously added case, and another option. So after I need to convert some options from base64 to array buffer, and now I will call navigator credentials get, not create, get. So I will receive some options here too. This is IDK and another options. It is not interesting. And after convert these options from array buffer to base64, I will send this data to my server to verify this information. So looks very simple. How does it look in the real world? Go to the browser. Yep, refresh page. Oh, try to sign up. Yep. My name is Sam, Sam2FA maybe. same gmail.com and QWERTY password. Password. So I have a second step for security key. It will be Sapphire. So, ouch, sorry, something wrong. Oh, just a second. I think I have some problem with this demo. I need to do. Yep. Just it will be enough. Okay. Try one more. And gmail.com and some password. Right. Sign up and my name. Okay. Yeah. Very good. How you can see, it is a native browser model. So, do you want to allow some app to use Touch ID? Yes. And second step, I will have a model for Touch ID, or an example, my watch. Yep. Very nice. And now I added this case. If I try log out and try to sign in. Yeah, I have second step for verifying. Yep. I have another model from browser and same model for touch my sensor. Yeah, in the app. If I will try add this key second time again, yeah, check. But insert a case and activate it to continue. Because I'm added a platform case in previously step, I can't do it anymore in the, for current account. Okay, nice. Cool. Maybe let's try to sign in from another browser. I have one computer with one sensor. I think it should work. Let's go to Chrome and try to sign. Oh, I need to sign in. So gmail.com, my password. Try to sign in. Yeah. Never. Try to verify. So built-in sensor. Oh, something went wrong. Okay, no problem. I did backdoor for this situation. So, and try. Now let's try to add a key from Chrome. Okay, Chrome. Check. Built-in sensor. I have. Model, touch. How you can see, a key was added. It is because Safari has an authenticator by Apple with its attestation. Chrome has its own, but uses Touch ID for verification. But if I remove my fingerprint from the system, the key in Chrome will still work. And Chrome will use the system password for verification. You can see one more exciting thing. Counter, it is for safe from reply attack. In Safari equals 0. Because Safari ignores this part from specification for own security reason. One more, Martin talked about authorize high-risk actions even when authenticated. I do it here, some very secure action, and now I try do it. And before something will be, I ask user to verify this action. I touch my sensor. Yep, action is done. Very, very nice. So, but I showed success way. But what about errors? When we work with WebAuthn, we can some error, catch some error. Example, if I will make a mistake in the option contract, if the user a long time not verify an action, will be timeout expired. And if the user has an old device without any authenticator or doesn't have an authenticator previously used for sign up, and some server errors. First, if attestation wrong or not has, ask me in QA session if you're interested in what is attestation. If credits received from phishing site, and if counter done correct. It is possible if authenticator was copied. And of course, we catch server error if server is down. So, what's cool in WebAuthn? First, it is so robust security based on public and private key approach. Second, minimum we require minimum action from users, and they know about that way from the mobile world. Wait, maybe try to do a resign in flow like in a mobile app. Go to the code. So, yep. Very nice. And it is for demo. Yeah. It will be work. All have the index page. Go to the index page. Yep. I added some model. Some model with some text for describe what's happened here, and two buttons: activate and cancel. So after first sign in to the app, we will run this code. In JS part, I call Java style method public key credentials is user verifying platform authenticator available. So if platform authenticator available, in result I will be it will be true result. Next, I have same code like in the second step sign up for that case, but I call my API with resign flag. It is flag affected to options. In options will be authenticator attachment platform. It is because I want to use only platform case, like in a mobile apps. Yeah, okay. Next, very same. I just call navigator credentials create and try to send to the server these options. But here I have a resign flag 2. And this is flag ask server. Server, please save this authenticator data to another session like remember me. So, and if all good, I will hide modal and done alert. And in the profile, in the profile when session expired, I will be show a resign button like in the mobile app, but in Chrome I can resign without button, but in Safari require some actions before calling WebAuthn API. So go to the demo. Okay, so no, I want to sign up. Send sign gmail.com and some password. Very nice, very nice. And so you can see I have a pretty model for pretty model. I just click activate and have some question from my browser. Do you want to allow to use Touch ID? Yes, I want. I touch my sensor. Very nice. Done. And so we will not wait time when session will expire. I create special time machine for this. Fasten your seatbelt and let's go to the future. Yeah, and a few moments later, I was my session was expired. Try to resign. Sign in. And you have some pretty other from my browser. Oh, sorry. Do you want to sign into this site as Sam Resign? Yep. I want. Touch my sensor, and I'm in the app. Very good. Very good. So, yeah, but I have one more problem. We still have password. No, I will skip it. Martin said about password-less approach. Maybe we can try it in my app. But yeah, passwordless it is not new way. You can solve passwordless by email or SMS, but it is not same in user experience and in the secure. Go to the passwordless demo. So yep, and go to the 5. Sorry, but good. Oh, yeah, 5 demo. Just a second. Yeah. Okay. Okay. So how you can see, I removed all parts for support passwords. Go look sign up page changes. Now here I have only 2 fields, name and email, and without any password. I like, but how I will yeah. Now from my API I will receive one more unique option, user verification, but I need every time verification what user will be do. So and I have a little bit catch for nickname, but it doesn't matter. Okay, I have a more time. Go to the demo and try to sign up. Oh, very nice. Sam and samgmail.com. Try to sign up. Yep. In the app. Very good. And if I log out and I want to sign up, I just type only my email, try to sign in, and touch sensor. Very less action. Very nice. Very nice. Go to the next. It's very cool. Now users can sign up and sign in very fast and simple. But can I do this way better? What about remove the login field? Just 2 buttons, sign in and sign up. It is like a dream. Let's go to try it. So, okay. Yep. This 6 demo, very nice. And oh man, yeah, I forgot through my environment, but no problem. I think we can. No. I need to show my code. I have only 2 fields, sign in and sign up, and some important two parts. When I try create sign, I need this option, require resident key true. It is for save some user data inside authenticator, and I will not have some allo credentials from server. Just go to demo. Okay. I will try sign up. So just touch my sensor and I'm in the app. Very good. Now I user 1 because I don't have any field. And if I try to sign in, sorry. Yeah. Some problem in. Okay, no problem. Has some mistake. And last part. If I lose my device.
Semyon, I'm sorry. We have like 1 minute before 100Z, before our break. So I guess you can show the last part in the discussion zone, and the link to discussion zone is right under my hand. So just please come to us to the discussion zone. I guess we can show Michael now. I'm sorry for interrupting, but I'm here to bring you the vibe of a conference. So at the usual conference, we have the same problem all the time. Like we just can't make it in time. I'm sorry. But I guess, Semyon, people will come to Zoom after discussion zone, and you will be able to show the last slides and the last demo there. And at this point, I guess we can ask Michael to the screen, to the broadcast, to say, and Martin here also, hey, I just wanted us all to say goodbye to our to people watching us, and some of you will go to watching like the break, and some of you please go to discussion zone. Bye.
Bye-bye. До свидания.